Alright everyone, it's Alec from Airsoft Mutation, and today I'll be showcasing how to install and epoxy the rack of the Jaeger MK2 to its body, and also a small kind of like Mythbusters, or I don't know how to say it, like just a small like informational video on why epoxy is very important for the proper function of a AEG piston, and not other adhesives like crazy glue or um, like mainly crazy glue, like epoxy versus crazy glue, and why epoxy is superior. So we'll start off with why it is important to epoxy your piston rack. And so the main reason why racks break is because not well, when they're not epoxied, why they break. It's not because the force is not being distributed throughout the whole piston. It is actually because on a lot of pistons, for example, this SHS piston, there is a gap right here between the piston, the pickup tooth of the body, and the rack itself. The pickup tooth of the rack and the body itself, the plastic support. So what happens when your sector gear comes and is spinning at high speeds and it impacts your pickup tooth? What happens is all that stress, all the force is being transmitted to this section here of the rack right here, and also the next tooth. So those are your two main stress points. And that is generally where a rack blows up. I mean, it sometimes it always happens, like maybe a bit more forward, but it will never really crack here unless you PME into oblivion and you actually hit here. But the main areas where you get cracking is right around here. And the reason why that happens is because of that gap between the piston body and the rack. So there's the other myth that I was going to say was the fact that the reason why pistons break is because they're not bonded to the sides. So the reason why I say this is a myth is because there is no epoxy on the market that will adhere well to nylon and steel. It's one or the other. It doesn't exist. You could search this up everywhere. I've looked for hours, if not days, trying to find an epoxy that bonds both of them. I've read hundreds of data sheets. It just doesn't work. So the other option is the only adhesive that I would say bonds to nylon and steel well are some crazy glues. So the issue with that is either epoxy or crazy glue. While it will bond to the sides due to repeated impacts and the slight flexing of the body, that bond between the plastic and the steel is gone. It will not bond. And you could take a piston that has never been PME'd, it is in mint condition, and because you epoxied it and all that, after like 100,000 rounds, and the rack will come out. It'll slide back out as if it was never epoxied. And that's because of it flexing, it bouncing and whatnot, and that bond breaking. So where most of your strength lies is the gap being filled on the body so that the force is actually distributed to the plastic and the rack at the exact same time rather than just the rack. Same thing for the front here. There is an extreme case of this. If you look at a SHS 14 tooth piston, so the one with the big giant rack, the gap here is like a solid millimeter sized gap. It is huge. A reason why that piston is quite solid and why you don't see those fail often, at least the ones with the silver rack, is because the sheer volume, the sheer thickness of the rack itself is just so much bigger than every other piston that it compensates for the lack of plastic. It compensates for that huge gap by just having immense tensile strength on the rack. I personally don't like that method because now you're at the grind teeth down and a bunch of shit. So not my preferred piston. So yeah, that is it is the main reason why you will blow out the back of a piston. and it's not because you bonded it and the force is being distributed throughout the piston. It is simply because that gap is being filled. I've tested this method on SHS pistons. I've tested on every single piston that I've owned. Literally just filling up that little gap right there is all you need to reinforce your piston. There are other, if you really want to make it strong, this is a method that FLT Airsoft told me about, and that is, so you do a combination of crazy glue and epoxy. So you have epoxy towards here and the front, and then you use crazy glue, or flexible crazy glue at least, on the edges after like sanding your rack for a rough surface. What this does is that you now have your epoxy for shock absorption on the two sides that prevent your rack from shifting at all. And then your crazy glue acts as the bond between the steel and the plastic. And that actually does work. If you use a flexible crazy glue, it's a lot of work, honestly. It is the best method, but for me, I find it's a lot of work. And when I have one of these, it doesn't really fucking matter, because I could toss this in with a bit of epoxy on the corner and run this at 70 RPS with an SP 190, and doesn't even care. It'll tank it, no problem. So yeah, actually, here's an example. Here's an old Jaeger with the prototype, the coated rack. This one I PME'd it at like 60 RPS on SP 160. Blew the siege tech spur axle clean off pretty much right away, and the piston, other than the scratches, is completely functioning. It works totally fine. I blew up the Etso bearing too that was under it. But yeah, so this thing will literally tank anything. And this did not have any epoxy running down the sides. It only had epoxy in the key areas that I'll be explaining pretty much right now. So on to the installation of, or the epoxying of the steel rack to the piston body, and also a brief explanation on what makes the Jaeger so strong. So what makes this guy so strong compared to every other piston on the market? And it is because of how the shock is distributed between the rack and the body. So on every piston on the planet, besides the Angel Customs Kratos, there are 2 points of shock distribution. One at the back, one at the front. There is nothing in between. It is just those two. The Kratos has a very similar design to this, where it gets thinner towards the pickup tooth, and that acts as a third kind of point of impact, and this takes it further by adding 4. So the 4 points are this little back section here, your pickup section, your inside where it starts getting wider for the whole rack, and the front. And the way this piston is designed, while it's not required, it is highly recommended for doing anything but basic builds to use epoxy, because of how I've built this. So how I've built this is done specifically to prevent your rack from sticking out the front here. And because of manufacturing tolerances, you can't have your dimensions always perfect to the point where this thing is always perfectly flush without maybe a bit of sticking out or a bit of pushing in. So I've designed it so that the rack sits a bit further back than the face of this piston here. Now, the reason why I did that is so that when you install this rack, when you make it flush to the face, you will then have gaps all like here and the 4 points, and that's where the epoxy comes in. And this is where it's important to use a epoxy and not a crazy glue, because crazy glue will be brittle, it'll shatter, and you'll have little bits of crazy glue floating around your gearbox, and that's not good. And in terms of epoxy, I'd personally recommend 3 choices, or any of so my main choice is Seccorp C-Tough. I've tested many epoxies. This stuff blows everything out of the water. This stuff is amazing. It is incredibly durable. It is flexible, and it bonds to steel and nylon decently well. Bonds to steel as well as JB Weld. Bonds to plastic about as good, but this has the benefit of being quite flexible. I could take a piece of this, like a millimeter thick sheet or a 2 millimeter thick sheet, and I could just bend it back and forth as if it was a piece of flexible plastic, whereas other epoxies would either shatter or just be too rubbery. This is my main epoxy. You could also use JB Weld. You could use any of the Loctite's rubber toughened epoxies, or any epoxy that isn't brittle and like kind of like flakes. So where to epoxy? You don't really need to use a lot of epoxy at all. You just need to use a very small amount. So there's 4 points to put this epoxy. You're going to want to put it towards the rear here of the piston. You're going to want to put some on the pickup tooth area. And you're going to want to put them on the inside here and the front. My tool of choice is a small tweezers like this, because it allows you to get into that crack quite easily. The other thing I forgot to mention is that you will need to hammer this rack out depending on your piston. Some of them are a bit tighter than others. You take a punch, preferably one like this that is flat, and you hit this front section here. So you put this on that front section and you just smack away. Don't be afraid to hit it pretty hard. It won't break. I've smacked these with incredible force to the point of like denting the rack and like chipping my punch. It didn't really do anything. The piston still works fine. And the last thing is where I'm about to put the epoxy, where the rack gets thinner and there's those rounded edges on the rack, and where the plastic body gets thicker. Depending on your piston, there may be like excess plastic dust in that small little area. Don't be alarmed. Just take a small tweezer, take an X-Acto, take anything that could fit there, and just clear out that small little bit of dust, and then fill it with your epoxy. So yeah, for this piston, you do not need to put epoxy throughout the whole track of the piston body. It's not needed. I am using this method here with this small little bit of epoxy in my personal DSG. It shoots on a large battery, 55 RPS with an SP160, a Garter SP160 spring. So it's not like it's low stress. It's pretty high stress build, nothing insane, but I've been using this method on that piston and it is not breaking anytime soon. So with the rack here, depending on which piston, on the piston you get, some of them are tighter than others. You're gonna want to either hammer this guy in, or if you know you could push it in like that, you could just take this and you're gonna want to push it down on a flat, hard surface. Do not push it in with your hand. Do not use a tool. Do not use a punch to push it down like this. You want to use a flat surface. The reasoning being is you do not want to push this rack past like the past being flush with the body, and you want to use the epoxy to then fill those gaps. So I'm gonna since this is like on a silicone mat soft, I'm gonna go press it down on my table to the left. So there you have it. Now this rack is perfectly flush against the body. And now comes the step of cleaning this just a bit. I would recommend using these precision Q-tips. You get these on Amazon or any store really. And just take this and go into the edges wherever there's epoxy and remove the epoxy. So now all these gaps are filled. You're going to also notice on the inside there's a little hole here. Just take your finger and just scoop that out like that. You could use another Q-tip to remove the epoxy that is kind of like built up on the rack so that can't flake off. And there you have it. Your piston is now epoxied to, your rack is now epoxied to the body. and it is, well, after 24 hours, it'll be ready to go in any build you so desire. All right, so your piston head is going to come in these pieces. So you're going to have your shaft, screw, spring washer, O-ring section, and your bearing holder, and screw. So what you're going to want to do is you're going to want to take these guys, this section here, apart. You're going to have your screw, your spring lock washer, your O-ring, and your shaft. So we're going to start with the shaft section. You're going to want to put your spring lock washer with the kind of like rounded edge like this, facing the top, and you're going to want the concave section facing the inside of your piston body. Now we're going to be using some thread lock for this screw here. Personally, for the front screw here, I would use red thread locker or something like bearing retaining compound, because you don't want this thing to move ever. This is kind of what holds this whole area together and prevents it, from blowing apart while it's cycling. This does kind of seem like a small part. I have personally tested this, and it is unbreakable. You cannot break this section, even though it looks kind of fragile. I've tried. You can't. You just break everything else. So you're going to want to put thread locker on this screw with spring lock washer, and you're going to just thread this in. I'm using Permatex orange, but you could use red. The orange stuff is pretty strong. So once that's in, you don't need to like jam it tight yet. You want to take your O-ring, put it around, and push it in. Another thing to note, this O-ring that is being used is one of those thicker SHS 5mm by 1mm cross-section O-rings. The one here in this case is a super resilient Viton O-ring, so it's not some like Buna N little O-ring. This thing is going to last for a long time. It's there as like a precaution rather than an actual necessary piece. The washer itself with the screw and the thread locking and all that acts as a seal as I tighten it, as the washer expands into the plastic. It digs into the plastic and creates a perfect seal. The O-ring is just there as a redundancy in case somehow through some fashion the washer doesn't seal. I've tried it without the without the O-ring, and it seals totally fine. So the O-ring is not really necessary, but it is there just in case. You're going to want to use a tiny bit of silicone oil on the O-ring. And then you're going to want to push this guy in. Can be quite tight. I'm just going to... There you go. I just pushed it down on my table. So now you're going to want to take this section here. This piston requires two 2mm hex drives. So for the bearing side, I'm using my longer screwdriver, and I'm just going to take this, slide it in, and you're going to have your little screw that's sticking out, and you're going to have your piston head. So you're going to then require a small amount of thread lock right here, and then you're going to want to put a very small amount of thread lock in the piston head. So for the piston head, I use a small little tool to kind of just poke that air bubble out so that your thread lock goes all inside the threads and doesn't just get pushed out the side. So then you're going to want to take this and just thread it on. Quite simple. Once you're somewhat near the end, you want to take your other hex drive and you just want to torque these two down. And there you have it. You have your fully assembled Jaeger MK2 and Whisper MK2 piston assembly. The last thing that I would like to point out is your screw does stick out. This should not pose a problem for pretty much every cylinder head on the market. If by any chance you check and it does touch like some part of your cylinder head, you can just remove the O-ring and it'll sit nearly flush with the face of the piston head, so that you won't be, smashing something with a hardened steel screw. So there you have it. Your piston is finished.